why do we go through the trouble of drilling ice cores in the first place? It's extremely uncomfortable and costly and takes a lot of energy. Well, ice cores allow us to investigate past climate and environmental conditions prior to the satellite era in the 1970s when it began, making them one of our most powerful tools for studying the Earth and climate and how humans have impacted both. The chemistry of ice cores offers a seemingly endless number of tools to investigate past climate. And I list here just a small selection of things that we commonly utilize ice cores for. We can reconstruct temperature in the past and atmospheric gases such as CO2 in the past. We can reconstruct wildfire frequency over time, and we can look at environmental contaminants to gain a deeper understanding of how humans are impacting even the most remote parts of our planet. And we can learn more about the world's oceans by measuring certain chemical species in ice that actually came from the sea. Now, you also might wonder, why can't we just drill an ice core or two and then we're done with it? Well, ice cores do contain global climate information, but they also have this incredible ability to tell us something more regional and local. So this is, of course, dependent on where the ice core is located on Earth. Our longest ice core records come from the polar regions, where ice has remained frozen for hundreds of thousands of years. But outside of the polar regions, there are very few places that are both cold and high enough to preserve long-term climate records. Mount Logan, in the southwest corner of the Yukon, and within the largest non-polar ice field in the world, is one of them. At 19,550 feet, Logan has the largest base circumference of any non-volcanic mountain on Earth, with a 12.5-kilometer-long summit plateau, 3-mile long, which is 3 miles across, that sticks up into the free troposphere. When we think of high mountains, we think of sort of pyramid-shaped things that don't have deep ice, but this is exceptional. It's a high mountain with a huge summit plateau that's sticking up all above 17,000 feet. And it's kind of a bowl. And we've long known that Logan, with this enormous, cold, high summit plateau, may possibly contain the longest record of North Pacific climate variability on Earth. That is, it may be able to tell us things about past climate in the North Pacific that, for example, polar ice cores, even ones in the Arctic that aren't too far away, cannot. Now, the summit plateau has all of the characteristics that we look for when we're drilling deep ice cores. Fairly stagnant ice, pretty much sitting there and it's not flowing too much. It isn't flowing fast at the base. Very cold mean annual temperatures. Never gets anywhere close to freezing, even in the height of summer. And lots of snowfall, meaning we have a high resolution record. The ice on Logan's summit plateau has remained frozen for tens of thousands of years, even in the height of summer. And again, this is pretty exceptional for a location outside of the polar regions. So I maintain what I've said publicly about this particular project before, that it's been the highest risk, but also the highest reward project of my career so far. And the primary goal of this project was to drill an ice core on Mount Logan summit plateau after locating the ideal drilling location, which took a whole second season. And the reason for doing this, like I mentioned, is to hopefully gain a long-term climate history in the North Pacific. And this is, of course, a really interesting project, in part simply because of the difficulty in drilling an ice core on top of a nearly 20,000-foot mountain. It requires a strong background not only in ice core science, but also in high-altitude mountaineering. And for me personally, this aspect has truly been one of the most special and rewarding. Logan has been a place where this has all come together for me for the first time, using all of my skill sets to achieve what I wasn't quite sure was possible.